Hello everybody and welcome back. In this video we're going to look at the derivation for the rate law expression of a third order reaction. Now for a third order reaction we can have it in three cases. The first one is when the three reactants are not the same. So we have this, and when just two of them are the same. So we have something like this, and at the end we have 2A plus B to give the product. And the last one is when the three of them are the same, and that's going to be 3A to give the product. So for this last one I have made a separate video for that, and if you are interested you can check out the link in the description section of this video. I'm going to include the link to that. So the one we want to look at in this video is when just two of them are the same, where we are going to be having 2A plus B to give the product. Now, in this case, you can write the rate law expression for this as K, maybe the rate constant is K2. So we have K2, concentration of A, because it's going to be second order with respect to A, then multiply by the concentration of B. So that's going to be the rate law expression. But we don't want to write it in this way. We want to include, because the concentration here we have for A is the concentration of A left after some time, and also for B is the concentration of B left after some times. Of course, we can actually write that in another way. Say for instance, the initial amount of A is small letter a, and that of B is B. So if you want to know the amount left, it's going to be the initial amount minus X, which represents the amount that has reacted. So when you remove the amount that has reacted from the initial amount, you have the concentration of A we had earlier on. Now, if you want to write that in form of X, so the X over the T would be, because we're having 2 of A, that will be A minus 2X to the power of 2, then multiply by B minus X. Don't forget to put the rate constant, K2, sorry, K3 in this case, because of course you can use anything, but just to represent that it is for third order reaction. So this is the differential rate law, and if you want to find the integral rate law, you need to integrate this. Now to integrate, you need to separate your variables, and that was the X over, so by the time you divide both sides by A minus 2X to the power of 2 times B minus X, you have A minus 2X square times B minus X, then you have equal K3 dt. It's very easy, okay? All right, so when you have this, it can be 1 over A minus 2X squared, then Bx times dx. These two guys are the same, okay? So I just try to express it in another form. So that's going to be equal to K3 dt. Now we need to integrate from here. So if you want to integrate with respect to x, so initially you won't have any x, that is, x is the amount that has reacted. So initial at time t equals 0, you won't have any x, that is, no amount will have reacted. But at some time t, some certain amount of x will have reacted. Now if you want to integrate, you cannot integrate this way. You have to make it such a way that we have a separately and we have b separately. So to do that, we need to use what we call the partial fraction method. You need to separate this fraction here into a partial fraction, and to do that we have 1 divided by a minus 2x squared b minus x. Now that will be equal to, so you separate it to a 3 fraction like a minus 2x, then plus b, because the total power is 3, so I want to separate it to 3 different fractions. So we have a, and we can also have b minus x first, b minus x, and plus c divided by a minus 2x, then square like that as we add it here. Now if you want to find, because we want to separate it to partial fraction in 3 ways like this. Now if you want, what you want to find from this partial fraction is actually the value of your a, b and c, such that when you input them into these fractions and you add them together, you're going to get the initial fraction. So one of the ways of solving partial fraction is to multiply the two sides by this denominator. So when you multiply by this denominator over here, by the time you multiply this by that, it's going to cancel, and you have something like a minus 2x squared b minus x. I'm multiplying this by 1 over a minus 2x square b minus x. Of course, they are going to cancel, right? Then equal, by the time you multiply this by that again, you will notice that only this will cancel one of this. And you have remaining, if you multiply by that, a minus 2x. Okay, let me do that separately. So you have a over a minus 2x, right? Then times a minus 2x, a minus 2x. That's the meaning of a minus 2x squared. Then times b minus x, right? One of these will cancel one of this, right? Then plus the same thing for this. Now we multiply this expression by this fraction. You notice that only this will cancel this. Then you have this multiply by, okay, let me do that as well. That would be over b minus x times, okay, a minus 2x squared, then times b minus x, right? Then you have plus c. Okay, the c is a c over a minus 2x squared and times a minus 2x squared b minus x. So, and also this cancels this as well. This cancels this. So notice that what you have here is just ordinary 1 at this left hand side. So we have just 1 equal. By the time this cancels here, we have a times a minus 2x then times b minus x. So we have a times a minus 2x then b minus x then plus b. Okay, so here now we have b times a minus 2x squared then plus c b minus x. So this is what we are left with. Now how do we get the value of a, b and c? Now if you want to get the value of maybe for instance, want to get the value of b, c first. So we can say that let a minus 2x equal to 0. If a minus 2x equals 0, that means that we're going to have 1 equal to a in bracket of 0 because this is now 0, then times b minus x, then times b, then this equals 0 square, then plus c. Now you're going to replace the value of b here in terms of a. So we now have b minus, now here now we have a equal to x. If a minus 2x is equal to 0, so then we have therefore x to be equal to a over 2 when you divide both sides by that. So we have x to be replaced by a over 2, and all this has become 0. We have a equal this time 0 0 plus this time 0 0 plus c in bracket of, when you find the LCM, that will be 2b minus a over 2. So we now have 1 equal c multiplied by 2b minus a all over 2. Then to get c, of course, you divide both sides by this expression a, and that will be c equal 1 over 2b minus a over 2, and that will be 2 over 2b minus a. So let's try and note that that's the value of c. Now if you want to find the value of let's label this equation 2, and this equation up here, this one equation 1. All right, so now after that you want to get the value of b and a as well. So to get the value of b, just make sure b minus x is equal to 0, so that all this goes and all this as well also goes. So then from equation 2 we have 1 equal let b minus x equals 0, and if it is equal to 0 then x will be equal to b. So don't forget, so when you put 0 here, we have a to the bracket of a minus 2x times b minus 0 b minus x is now 0, then plus b in bracket of a minus 2x squared, then plus c in bracket of 0 now because x minus b minus x is now 0. So we now have 1 equal 0 plus b a minus 2x squared then plus 0 again. So now have a equal 1 equal b a minus 2. Now x will now become b, so that will become 2b now, so times to the power of 2. So now we now have b to be equal to 1 over a minus 2b squared. Now I want us to make sure that we note all this. Let me put them in red so as to note them easily. then A is yeah, we got C already, so this is C, 2 over 2B minus A. Alright, so now to get A, that's a little bit complex because there's nothing we want to cancel out A that's not part of A. If you try to cancel A minus 2x is A, it's going to cancel A, and also for B minus x it's A. So the best thing is to open the bracket. Now to open the bracket, it might seem, a bit complex, but that's what you can do. Now look at that. From here, if you open the bracket, we have 1 equal, let me change the, so we now have 1 equal A multiplied by AB minus AX. You need to be very careful here. Use this to open the bracket. Then we have minus 2BX plus 2x squared in bracket. Then plus B. This is A minus 2x. A minus 2x. Then plus, you can say CB minus CX. Now we have 1 equal ABA. Using A to open the brackets, then minus AXA, then minus 2BXA plus 2x squared A, then plus B in bracket of A squared minus 2AX minus 2AX plus 4x squared, and plus CB minus CX. Alright, so now I have 1 equal ABA minus AXA minus 2BXA plus 2x squared A, then plus B in bracket of A squared minus 4AX, this and this, okay, then plus 4x squared plus in bracket, okay, plus CB minus CX. Alright, so we have 1 equal ABA minus AXA minus 2BXA plus 2x squared A, then plus A squared B. Now I'm opening the bracket now. We have 4AXB, then plus 4 x squared B, then plus CB minus CX. Now the next thing is to separate them based on the variable of x. So we can start with x squared first. So we now have 2ax squared. Okay, another x squared is plus 4bx squared. That's out as well. And I think there is no more x squared again. So now let's continue with x. So that will be minus 4abx, also minus 2bax, also minus aax, and finally no more x. Okay, now to the constant aba. A constant, I mean the one with no x. So now I have plus a squared b, then okay, then plus cb. Don't forget we have minus cx here, so we are supposed to put minus cx here. Okay, so now I have 1 equal 2a. We want to factorize the x plus 4b, okay, x squared now, minus all of the x as minus, so you can factorize minus out. 4ab minus 2ba, and plus, to be plus now, okay, a then minus c, now of x, plus aba, then plus a squared b plus cb. Now the one that's very important here is actually the x squared. Now you want to compare the variables. We have the x squared, x, and the constant. So of course the constant is equivalent to 1 here because 1 is constant. If you look at this side, we have just 0x squared. That is, we have no x squared and no x as well. Then plus 1 as constant equal all this side. I don't need to repeat myself again. Okay, so it's equal to all this side, right? So it's equal to 2a plus 4b x squared, then minus all this side, you put it again. Now the one that's important is that you want to compare the variables of x squared with the one here. If you write all this, you can compare that all this in bracket, which is the variable of coefficient of x, will be equal to 0 as well. And of course all these ones that are constant will be equal to 1 because 1 is constant a. And I believe you understand what I'm trying to say now. So that means that the coefficient of x squared a, which is 2a plus 4b, will be equal to 0 because coefficient of x squared at the left hand side is 0. So by collecting the like term, we have minus 4b. And a here will be equal to minus 4b divided by 2, which is minus 2b. So a is minus 2b and a is minus 2 in bracket of, now remember b was 1 over a minus 2b squared. 1 over a minus 2b squared. So your a would then become minus 2 over a minus 2b squared now. So that's the value of your a. So we've gotten the value of our unknowns now. So from here we can see that our equation is now meaningful from equation 2. Don't forget this equation 2 over here. Okay, it's even equation 1. So you can now substitute the value of a, b, and c to your equation now. Alright, so let's substitute that. So from here, we see that now to make things easy for us, if you have b divided by, even from here, as we had it here, it can be a times 1 over a minus 2x. And the same thing with b, it will be b times 1 over b minus x, like that, and like that for c as well. So that's how I'm going to do that, because all of them, a, b, c, they are also fractions. So to make things easy, starting from a, this expression here becomes minus 2 over a minus 2b squared, then times 1 over a minus 2x, then plus b as well. Don't forget, b is 1 over a minus 2b squared. So that would be 1 over a minus 2b squared, then times times 1 over b minus x, then plus c was 2 over 2b minus a, 2 over 2b minus a, then plus 2 over 2b minus a, then times 1 over a minus 2x squared. Then all this equal to this. So by the time you multiply, you have it equal to minus 2 divided by a minus 2b squared, then times a minus 2x, then plus 1 over a minus 2b squared, b minus x, then for the last term, that will be 2 times 1, 2 divided by 2b minus a minus 2x squared. So this is the equivalent expression for, and you can see now that all the constants are now separate and all the x now they are also at another side. So we can have 1 over a minus 2x squared b minus x. Now do not forget, we try and solve this into partial fraction now. So this fraction here that we could not integrate has now been resolved to 3 partial fractions. So we're not going to bring back our integral from equation 1. Remember, sorry, not even here, the first one, yeah, from here. Don't forget this equation. This is what we need actually. We want to integrate. So to do that, okay, so we're not going to say that remove this expression here. Let me try and cut it, since we have been able to. Alright, so since we have been able to do the stuff, we can now cut, we can now delete everything now. Alright, so let's continue from here. Now we have to replace this expression here, okay, with integral of all these three. So it's going to be integral from 0 to x. Now removing this expression, I'll put the partial fractions. That will be minus 2 over a minus 2b squared, then a minus 2x, all this in brackets actually, then plus 1 over a minus 2b squared, b minus x, then plus 2 over 2b minus a minus 2x squared. Yeah, that's all. Then all this, because all this here is like this, okay, then which is equal to all these I've put in here. So that's going to be dx then times dx equal the integral from 0 to t k3 dt. And then we have to open the bracket with dx. So you separate the integral for them. That's going to be integral from 0 to x of minus 2 over a minus 2b squared a minus 2x dx. Then plus the integral from 0 to x of 1 over a minus 2b squared b minus x plus dx. Then from 0 to x again, 2 over 2b minus a minus 2x squared dx equal the integral of from 0 to t k3 dt. Now from here, I can separate out the constants. So that will be minus 2 over a minus 2b squared. That's the constants from 0 to x, 1 over a minus 2x. I believe you understand this. We don't need much explanation on that again, because it's like this times 1 over this. So it's just mathematics. Then plus, do the same thing here. That will be 1 over a minus 2b squared, the integral from 0 to x b 1 over b minus x dx, then plus 2 over 2b minus a integral from 0 to x 1 over a minus 2x squared. Now it's time to integrate this. This is the constant. Bring it out from 0 to t dt. Of course, we will have done this before, but I just choose to leave it like that. Now to integrate, you have to revert back to the first video I made about the integration, about the review of integration and differentiation, because I will not be able to explain that again here. But if you are already good in mathematics, you understand how I'm about to integrate this now. So it's already complex. I don't need to explain much about this again. Now don't forget, this is like a minus 2x to the power of minus 1, right? So that means that you are trying to integrate this from 0 to x, okay? So the integration will simply be, it will be ln a minus 2x then divided by the differentiation of minus 2x, which is minus 2, from 0 to x, then plus 1 over a minus 2b squared. Of course, this will simply just be minus ln b minus x. Again, if you do not understand, revert to the first video I made on the review of integration and differentiation. This from what I'm looking at here, if you integrate that, it should give you it's a minus 2x to the power of minus 2. So that will be integration of this dx. This should have dx. Okay, so dx, that will be a minus 2x minus 2 plus 1 and divided by minus 2 plus 1, and that will be a minus 2x which is power minus 1 over minus 1 and times 1 over minus 2. So the answer will be 1 over 2 times 1 over a minus 2x. So the answer will simply be 1 over 2a minus 2x. Good. So that's going to be the answer for that. So let's try and write it here. 1 over 2a minus 2x from 0 to x. Alright. So now don't forget, after integrating, it is equal to k3 times the integral of dt is t from 0 to t. And then we have minus 2 over a minus 2b squared. Now this becomes, before you even introduce your limits, you can actually factorize, because it's a constant, times 1 over minus 2, okay, then ln a minus 2x from 0 to x, then plus 1 over a minus 2b squared You can also multiply minus 1, you can factorize that out, and you have ln b minus x from 0 to 1. Also, we have plus 2 over 2b minus a, and 1 over 2a minus 2x from 0 to x. Now, by the time you substitute your limit here, we have k3, then t minus 0. And we have, now, we can now put our limit. Now, don't forget, this can cancel this out, and we have just 1 over a minus 2b squared. Then, in your limit, we have ln a minus 2x, then minus, by the time you put 0, it will be ln a minus 2 times 0 is 0. So that means that you put it like that, then plus, this becomes minus, so it will become minus now because it's like times minus. So it was plus 1 over this before, then times minus, it becomes minus again. So it's now be minus 1 over a minus 2b squared, ln b minus x, then minus ln b minus 0, that will be ln b, and plus, plus this one, the last one, that will be 2 over 2b minus a. Okay, that will be 1 over 2a minus 2x, then minus 1 over 2a. By the time you put 0 here, that will be a minus 2 times 0, a minus 0, then that will be a. So 1 over 2 times a. Don't forget, that will also be equal to k3t now. So it's because of the screen size. So this will now be 1 over a minus 2b squared. Then now, don't forget the rule of logarithm, ln a minus 2x over a now. Then minus 1 over a minus 2b squared. This a. Okay, then times, we now have ln b minus x over b, then plus 2 over 2b minus a. Of course, you can find the LCM here, and that's going to be, from here, that will be simply be 2a minus 2x times a. And then by the time you divide this, that will simply be, a minus, in bracket of a minus 2x equal k3t. Then we have, it's like multiplication. So we can have ln a minus 2x over a, then divided by a minus 2b squared. Then minus, also we have ln b minus x over b divided by a minus 2b squared. Then plus, we now have 2 over, this will be 2b minus a, then times the denominator of this one, which will be 2, a minus 2x, then times a as well, then times, now this becomes a minus a plus 2x, so this will be 0 plus 2x, that will be 2x, okay, then equal k3t. We now have ln a minus 2x over a minus 2b squared minus ln b minus x over b over a minus 2b squared, then plus 4x over, now 2 can actually cancel out, don't forget that, so 2 can cancel out, and if it happens like that, we just have 2x divided by a in bracket of 2b minus a in bracket of a minus 2x, then all equal to k3t. So this is the expression for that, and if you are asked to find the rate constant, of course you just have to multiply both sides by 1 over t, divide both sides by t, and if you have to find the half-life, just substitute for your x, you substitute a over 2 for that, or b over 2 as the case may be. And that is all for this video. Thanks for watching, and don't forget to subscribe to this channel and like this video, and make sure you comment down below if this video is helpful for you. Thanks for watching, and if you are interested in joining our online class, it's currently ongoing. The registration is currently ongoing. You can just message on WhatsApp Team DALECHEMY tutorial if you are interested. We have a lot of courses for 300 level, 200 level, and other level courses. We have carbon ion CHM 331, and we have CHM 301 as well. If you are interested, you can just DM us on WhatsApp. I'm going to paste the number you are going to message in the description as well. So thanks for watching, and don't forget to subscribe. Bye.